Today, we're charting our course amongst our solar system neighbors as we get set to launch Rooftops of the solar system. Hi, I'm Skye Marthaler, and welcome to the first episode of Rooftops of the Solar System. You may be expecting a slightly different episode today, but we're going to take a small hiatus from our regular Earthbound series to do a bit of what if, and to let our imaginations run a bit free while we stay safe at home. So over the next few months, we're going to embark on a journey to the highest of high points and geological wonders in our celestial neighborhood. If you want a bit of flavor on what this series is going to be like, then check out the Moon episode that was done last year. It is, for all intents and purposes, the pilot episode for this series. And while you're at it, click that red subscribe button below and the bell icon next to it for all the latest Rooftops of America updates. Imagine, if you will, getting the high-pointing opportunity of a lifetime. The chance to experience the tallest mountains and most remote places in our small corner of the galaxy. This will be a journey unlike anything else as you travel out into the final frontier. This is a quick overview of what you can expect. And it all starts with the brightest object in our sky, our sun. Our solar system is anchored by our sun, a yellow dwarf star. While smaller than a majority of stars out in the galaxy, it dominates our local part of space. The rest of the system is everything that is gravitationally tied to it, including planets, dwarf planets, moons, asteroids, centaurs, comets, down to the smallest parts of debris. To give you an idea of just how big and influential our sun is, consider that it is made up of 99.8% of all the material in our solar system, and its gravitational influence extends to places that we have only theorized to exist. But you can't high point the sun, so as beautiful as it is to watch the coronal mass ejections and the solar flares, well, we have to limit our explorations to the remaining 0.2%. On this grand tour, we'll begin with the scorched iron rock closest to the sun, Mercury. This speedy world is one where impacts and collisions have shaped its history and appearance. Covered in craters, Mercury is baked and blasted by the sun during the day, only to plummet into an icy cold at night. Despite its small stature, it is the teeniest of all the major planets. Mercury still keeps some big secrets. Why is it shrinking? Why is its core so massive in comparison to its outer layer? And how much water is actually on the planet? And why is its orbit so weird? These are just a few of the riddles that have yet to be solved. Departing from Mercury, we'll head outward to our evil twin, the cloud-covered world of Venus. It's as close to hell as we'll encounter on our journey, a world of volcanoes, unrelenting heat, and pressure. It is also a treasure trove of geological wonders with features not found elsewhere in our solar system. Of all the worlds and moons we visit, Venus is the one that requires the most suspension of disbelief. It is an incredibly hostile world to both man and machines. In theory, with our current technology, it would be possible to outfit an astronaut to walk on the nighttime side of Mercury, or on the moons of Jupiter, and while it may be a bit far-fetched, perhaps even on the icy, barely above absolute zero, frozen plains of Pluto. Venus, on the other hand, is in a completely different category. It would be hard enough to get a machine on the surface to function for any significant length of time, let alone to put a living being on the surface that could survive more than a few minutes at best. After our crushing and burning Venusian experience, I think it'll be time to head home for a little bit, get a chance to refit and catch a little R&R. But don't think we won't be doing anything while we're here. Our planet is a unique geological wonder in its own right, and this gives us a chance to explore what makes it special in our solar system. Our home in the cosmos has so far turned out to be a bit of a rarity. A large moon stabilizing our planet, a strong magnetic field, copious amounts of liquid water, and the only place we know of so far that has life. Our planet is dynamic, a world that has some amazing features in its own right. Incredible rift valleys and canyons, rivers, and a variety of mountains and climates found nowhere else in our solar system. Blasting off a second time, we now turn our attention to the outer planets and the long journey it takes to reach them. Our first stop on our outward journey is the last terrestrial planet, Mars. While the red planet is the second smallest of the major planets, don't let that fool you. Mars is a home to giants. On its surface are geological features that make others in the solar system pale in comparison. Of the 10 tallest mountains in the solar system, 4 of them are going to be found right here on Mars. It also has one of the largest impact craters and is home to one of the longest and deepest canyons in our solar system. And at one point in its history, Mars was also home to one of the largest waterfalls in our cosmic neighborhood. We'll travel through the asteroid belt for now, and return and visit it on our way home. We've now reached the frost line, the place where simple molecules, in this case water, stay frozen permanently, even in direct sunlight. The frost line serves as a very convenient border between the terrestrial planets and the realm of the gas giants. There's going to be no highpointing on these monsters, but they provide many alternatives in the form of their moons. If you were to view our solar system from afar, you could easily get the impression our star only had one gas giant companion. Jupiter truly is a giant. You can mash all the other planets inside it and still have room to spare. Put this in perspective. Of the remaining 0.2% of the materials left over from the creation of our sun, Jupiter used half of that in its formation. Jupiter at present has 79 moons, but the ones we'll be most interested in are the 4 Galilean moons. These moons revolutionized our understanding of our place in the cosmos. Ganymede, the largest moon in our solar system. Callisto, one of the most heavily cratered objects we know of. Europa, a frozen ocean world that is a potential home for life. And Io, a world truly of fire and ice. After our visit with the king of the planets, we'll journey on and meet the queen, the ringed beauty that is Saturn. The moons of this gas giant are some of the most diverse in our entire solar system. A prospective explorer could easily spend several lifetimes exploring them all. As of 2020, there were 82 at last count, the most for any of our local planets, ranging from massive atmosphere-rich Titan to spongy potato-shaped Hyperion, from the yin and yang of Iapetus to tiny Pan racing through the rings. On our journey, we'll look at some of the biggest and most unique moons in the Saturnian system. Our adventures now take a turn into the cold domain of the ice giants. Here's where things get harder as we step off into the unknown, or, at best, barely explored. Only once in human history have we ever seen these places up close, when Voyager 2 visited them in the 1980s. These two worlds remain distant, remote, and mysterious. Our first ice giant is perhaps the weirdest planet in our neighborhood, Uranus. When Voyager visited in 1986, Uranus got a reputation as a boring and bland world. But in reality, it is so much more interesting. Tipped over on its side with an east to west rotation, this ice giant is a ball of methane, water, and ammonia, and is the coldest planet in the solar system. Uranian weirdness also extends to its moons, an odd collection of 27. There are shepherd moons in its rings, some on paths to destruction. Then the larger ones of Ariel, Titania, Umbriel, and of most interest to us, Miranda and Oberon. The second of the ice giants is a blue jewel almost 3 billion miles from the sun. It too has moons to explore, but here it's like exploring the ruins from the distant past. Triton, Neptune's largest moon, dominates the scene, but a quick look will tell you it showed up later to crash the party. Neptune's moons are a peculiar bunch, because Triton's arrival threw the whole Neptunian system off. The original moons that survived this catastrophe are misshapen and odd. None of them are spherical, and some are the darkest objects yet discovered in our solar system. In addition to Triton, Proteus and Nereid will be of interest. With the major planets now completed, it's time we head into the wild frontier that's the Kuiper belt. Long theorized, when it was officially discovered in the 1990s, it turned our understanding of the solar system on its head, basically doubling our cosmic backyard in size. Our first stop here will be its most famous member, Pluto, who, for most of its observable history, was at best a blurry blob. It even had the unfortunate occurrence to be demoted from the ranks of major planets. Now though, Pluto's reputation is in the ascendant. Recent discoveries reveal a dynamic, fascinating world. The dynamic duo of Pluto and Charon will be the end of our outward journey. While there are other dwarf planets beyond, such as Eris, Haumea, Makemake, to name just a few, we know little of these worlds other than they exist, tiny specks of light in our telescopes. The images here are merely speculation on our part. But if they are anything like the larger Kuiper belt objects we have already encountered, then we could potentially encounter dynamic geological environments with mountains yet to be spotted and one day climbed. The crazy truth is our solar system is so much bigger than we ever expected it to be. There's a whole nother region that's theorized to be out there, at the far end of our sun's gravitational influence, the enigmatic Oort cloud. Who knows what geological wonders or high points could exist way out in the realm of long-cycle comets? At this point, we have yet to see a single Oort cloud object in its domain. There is also the theorized Planet 9, a distant world whose influence has only been seen in the effect it has on other neighboring celestial bodies. Perhaps it is a long-lost gas giant from the early days of our solar system, or a rogue planet captured by our star. As we turn around, it's time to head back to the place we skipped on our way out, the asteroid belt. The asteroids could best be described as the ancient wreckage of a battlefield. Most of the material originally in this zone was destroyed or flung away during the early days of planet formation. The asteroid belt is usually pictured on maps or charts as quite a crowded area, but the reality is far different. There is a lot of space out here, and the asteroids themselves range in size from several hundred kilometers in diameter down to particles of dust. They are a fascinating collection of objects, some with moons or icy surfaces, or even some that are barely holding together. Two, though, are of particular interest to us. The first is the largest and only spherical member of the asteroid belt, the dwarf planet Ceres. Compared to its colleagues, Ceres is massive, composed of 40% of the material in the main belt. The other of interest is Vesta, the second largest asteroid, and it is here where our journey will come to an end, and we'll reach the ultimate goal of our solar system highpointing adventure. And there you have it, our itinerary for our solar system adventure. I'm Skye Marthaler. Join me as we boldly go where no highpointer has gone before on Rooftops, the solar system. Before you go, click that red subscribe button below for all the latest updates. And let me know in the comments below what planet or moon or asteroid you're most looking forward to. I'll see you soon.